When you think of a data warehouse, what image comes to mind? For me, prior to joining Snowflake, I was at Tableau. And when I used to hear customers say they were building a data warehouse, we'd kind of think in the back of our heads, yeah, it's this unicorn that no one actually achieves, right? It's a single place for all your data, and it's going to service all the business needs. And for some reason or the other, every time we saw this project, the same sort of thing started to happen, and I sort of doubted that this thing existed until I took a closer look at Snowflake, and hopefully by the end of this talk, you guys will see why that is. Now, at Snowflake, our mission is to enable every organization to be data-driven. And so, of course, I mean, the insights and analytics track, hopefully this will ring true and sound quite appropriate to everyone in the room. But this mission is a big one, and we're only a small piece of it, of course, right? Every business wants to make better, faster decisions based on their data, but for one reason or the other, and they're limited by existing technologies. So our founders saw these problems, and they saw them fit into a couple of different buckets. They were both at Oracle, and so they were sort of in the trenches there. They saw the limitations of legacy architectures. They saw the complexity involved when data got really big. They also saw the complexity involved with things like Hadoop. And so everyone was talking about Hadoop at the time, but they sort of decided to take a different route. The scalability of these systems tended to be limited. So you're having to schedule things at the right time, make sure that you've prioritized requests and so on. Elasticity was a problem in terms of scaling. So even if you could scale, it required a lot of work, a lot of fine-tuning. Cost is, of course, always going to be a problem, or at least a limitation with how big you can go with some of these systems. And then finally, diversity. So the types of data that you can actually ingest tend to be limited. It had to be structured, for the most part, for a lot of the relational sources. And so what we built at Snowflake, at a very high level, is three things. The first is that it's a SQL-based data warehouse. So we're fully ANSI SQL, which means it's really familiar to use. Again, our founders bet on SQL. They just said we need to build a better SQL data warehouse. The second is that we were built specifically for the cloud. So that just means we're using the cloud infrastructure. We are using the AWS Fabric to deliver something that's scalable and flexible, the way that the cloud was meant to be. And then the third is we are full service. So we are a data warehouse as a service. We provide the platform to you so that not only is there no infrastructure to manage, but there's also no tuning, no manual indexing, partitioning, backups. That's all taken care of. And how we do that is with a completely new architecture. So traditionally, databases and data warehouses tended to fall into one of two categories, right? And both of them had their limitations. So shared disk, you tended to see a lot of contention. You're really limited by the box that you're running. And so that was, of course, not going to be the way forward as data sizes grow and so on. Shared nothing was slightly better. It was the distributed way of approaching things, and that sort of works. What we've heard, though, is scaling these architectures is still a lot of work, still takes time, and it's not instant like the way you expect it to be. And so the brand new architecture that our founders built, we call it the multi-cluster shared data architecture. Essentially, we've separated the storage and compute layers from the ground up. So when you load data into Snowflake, you are paying for just the cost of S3 at that point. We pass on that cost to you, we don't mark it up. Now, when you need to do something with that data or add more data into the system, that's when you spin up compute clusters. So you could spin up a 2-node cluster here to load some data in, a 1-node cluster to do some transformations, and then perhaps another 3rd cluster here to query the data from a BI tool. All of these clusters do not interfere with each other. They're essentially dedicated resources for each workload. And that gives you, again, huge flexibility and no contention. Now, being a cloud-based data warehouse and a full service, of course, security is very important to us. One of our biggest customers in the US is Capital One Bank. And so we had to, of course, go through lots and lots of security reviews with them and many other organizations. And so when it comes to authentication or access control, everything's there that you'd expect from MFA, SSO, and role-based access. But we also do things out of the box, such as data encryption. At rest and in flight, all of your data is always encrypted. You can even bring your own key to the system if you want. And then we have external validation available as well. So PCI compliance, HIPAA for healthcare. And now we've just gotten FedRAMP quite recently for government. Now, thinking about how this might look in your environment, it all starts with the storage piece. So that's that bottom tier of our architecture. And again, that's S3, under the covers. They're S3 buckets managed by Snowflake. In terms of how you store your data in Snowflake, it's up to you. So although our name is Snowflake, we don't only support Snowflake schemas. You can bring a star schema, you can do a data vault, whatever you want. And our global services layer, that's really where Snowflake is. That's our IP, right? So the global services layer handles the security, the logical model. And because it is cloud, you can grow this to as big as you need it to go. So we have customers in the US with petabytes of data in a single table. Now, surrounding that storage layer is the compute. So again, it's completely separate, completely decoupled. And each of these gears just represents a cluster of machines, so EC2 machines. And the size within each of the gears represents how big or small that cluster is. So we use t-shirt sizes. So an extra small is a single node, a small is 2, a medium is 4, and it just doubles each time. We generally will see linear scaling, and I'll talk about scaling in just a sec. Now, to get data in, you need compute. And so in this case, you might spin up a single node, extra small cluster. Some files that's sitting on S3 are coming from your apps. You could just load that in directly. Or you can push it through an ETL or EL tool of your choice. Again, we have ODBC and JDBC connectivity, and some of these tools also have optimized connectors. So that's more for batch loading. Streaming is also supported through something called Snowpipe. This is serverless. So under the covers, it actually uses Amazon SQS, but essentially it will stream your data in as it lands in the bucket. And so there's no manual provisioning at all on your part. Now, getting the data in is one thing. Now, once it's in Snowflake, again, because we're a SQL data warehouse, you can plug in whatever BI tool you already use. So the ones we see most often are here on the screen, but again, JDBC, ODBC. So the important thing here as well to note is the separation of the workloads, right? So again, contention is usually an issue on some of the traditional databases. In our case, if we separate the ETL on its own cluster and the sales reporting on another cluster, they do not have to compete for resources. And so there's not contention like you would typically expect. That means you don't need to do your ETL or your load in the middle of the night anymore. You can do it all throughout the day if that's the business need. Same goes for maybe your data science models that you're running, right? You can push that through a separate cluster and utilize our Python connector, our Spark connector, and do those queries directly on the same storage. Okay, so scaling. Again, we're built for the cloud, right? So we're really elastic when it comes to scaling. And there's two main ways we scale. The first is you need a faster engine. You need more compute power. You need to run that thing faster. And we can do that in a single command. So it's just an alter size to whatever. And so you could go, for example, from a small cluster here, and in a single command or a single click, increase that to an extra large or 4XL or however big you need that to be. Adobe does this to load their data in every week. They get data from third parties, and they spin up, I think they spin up like 10 4XL or something crazy like that and get it done in a fraction of the time they used to have to do it. The second way we scale is more for concurrency. So this is your typical end of month reporting, Monday morning sales team trying to see their reports. In this case, we can detect queuing of requests. So the queries themselves aren't necessarily more complex, so you don't really need a bigger car in this case, right? You just need more lanes on the freeway. And so what we can do here is we can automatically scale horizontally to accommodate for that concurrency peak. All right. In addition to all of that, so in terms of scaling, our biggest thing there is just being elastic, being on demand. We also support semi-structured data. And so things like JSON, XML, Avro, Parquet, we can adjust that as is, and we do a schema on read. So we provide you with basically SQL extensions to reach into hierarchies. We have a flatten function for things like arrays. And all that means is you treat that data as a first-class citizen. You don't have to push it through a separate pipeline. And if the structure changes, which it often does, it won't break anything, right? The data will still be loaded, and then you just adjust your query on the other end. The other thing we can do here is really utilize, I guess, the fact that we are using cloud storage, and we can do things like zero-copy cloning here. So we can essentially take a metadata copy, a pointer copy of entire databases instantly without having to copy the actual files. So we can create a clone. Maybe we're going to create a clone for test dev, for this example. It's free, right? Because we're not actually creating new files. It's fast. And then you have a full set of data to do test with. Only at the time that this data changes do you have to pay a delta in terms of that storage cost. But again, storage is cheap in the cloud, right? So this is sort of a little bit more about how that zero-copy data cloning works. Again, metadata only, no actual data is copied. The other thing that we provide is something called continuous data protection. So all the files sitting on S3 are immutable. So any updates you make on your data will not modify existing files, right? We'll create new ones. And then when you commit the change, we'll point everyone to the new copies. And that means the old files, they're still there. We actually keep them around on purpose for, by default, it's 24 hours, but you can set that all the way to 90 days if you want. And what that means is if I drop a table by mistake, which sometimes might happen, or if I update a table and it corrupts, I can essentially go back in time and restore that entire set of data without having to do the traditional backup and restore. So comprehensive data protection is, again, built into the product. We're, again, trying to make it really easy for you to use and to make sure that you're not going to be left with some manual effort and downtime on the system. Obviously, everyone hates that. No manual backups, no test dev environments that you have to manage separately, right, with clones. And then the last piece here is more around the sharing of your data. So we enable data sharing, and we're seeing this more and more. So as an example, one of our customers in the US and actually in this region now is Blackboard. And so what they do is they use our data sharing capability to share data that lives in their environment with all of their customers. And what's different about the way that we share data is that it doesn't require actual data movement. So if you think about the way that data sharing might look today, it's usually one of two ways, right? You either, well, hopefully more than 4 gigs of data and it's not on a USB stick, but you get the idea, right? You have to take the data, you have to upload it somewhere, and then the same thing needs to happen on the other side. And again, as that data size grows, that becomes really cumbersome, and it's not just a one-time operation. You might have to do that over and over again every time the data is updated. So it's very archaic, but you see it a lot. Or you might have to build an API, and this is I guess we see this more and more. But again, that's another thing you're gonna have to manage, maintain, and of course build documentation and do all that stuff around, right? So it's not exactly the most straightforward either, and not necessarily what your teams want to be spending their time on. And so the way that we approach data sharing is slightly different in that your data will stay in your account in Snowflake. You can provide secure access to a subset of the data via a secure view with an external party. And what that means is they can see the data, they can read the data, but again, it doesn't actually move. So it exists still in your Snowflake account. And what the second part about that is that it's live. So any updates will just flow through automatically. There's no manual effort or regular updates you need to run after that first share has been created. So we're seeing more and more of this happen. We're seeing huge use cases. In Australia, we have a couple of healthcare providers that are trying to see how they can share data around trends of claims and things like that. Again, in a secure way. People want to do this in a way that's not going to compromise the security of the data underlying. So customers are sort of using Snowflake in obviously various ways. We are just a data warehouse, so it's not like a single industry, and it's not even a single data size. Yes, we can go really big, but we also have startups that start with Snowflake, and the main reason for that is you can start small. You can put data into Snowflake, again, just in that S3 layer, and you can keep adding to that as you go without having to re-architect the entire system, right? So the types of customers we serve are quite common, but across the board, they tend to look similar to what we're seeing here, where, of course, you have tons of data sources. You might land them in a staging area, and then some of your semi-structured IoT mobile app stuff maybe goes into a data lake. They then maybe push all of that data into a central data warehouse, and then create data marts or perhaps extract data into their BI tools to then serve their end users, whether they be internal, external, whatever. Now, with Snowflake, what we're seeing is two things. On the one side, we're seeing sort of not a replacement always, but a convergence perhaps of some of the data lake type use cases. And one thing I will mention here is that, yes, we do semi-structured, but we don't do unstructured data, right? So Snowflake doesn't store unstructured, so that's sort of where that line is drawn. But for the semi-structured stuff, again, because we handle JSON natively and because we allow you to query it with SQL, you could put that into Snowflake, have it right alongside your other data, and not have to, again, manage an entire another platform, essentially, for that, right? The other thing I didn't mention about JSON is that we can also query that pretty quickly. We find that the performance difference between the JSON and the structured is not significant at all. And the reason for that is under the covers, we're actually doing a lot of optimizations to that data. So when you load data into Snowflake, we actually we partition your data automatically. We break your data into what we call the micro partitions. We run statistics on those micro partitions, and then our services layer essentially will hold all of that metadata surrounding the partitions. Right? What that enables is for us, when you run a query, we can run that query super fast because we should see really good pruning. You might have a table with 100,000 micro partitions within it, or even millions of micro partitions. But when you run a query, we don't want to see the whole thing come back, right? We don't want a full table scan. We should see just a subset of those partitions be returned. And so on the consumption piece, rather than have to rely on a lot of data marts and extracts, we're seeing a consolidation of all of that, and just being able to use views, right? Just being able to utilize live queries, which we're seeing more and more through some of the more modern BI tools. So what that does is, of course, gives you the live data, but it also means you're not having to worry about all these silos that are popping up in some of your BI tools because of a performance limitation. We actually had a customer in the US, a big streaming media company. I probably don't know if I can say the name, so I'm sure you guys can guess who it is. But they were using Tableau at the time, and what they were finding was that they were relying too much on extracts, and they were reaching the limits of what an extract was meant to be doing in the first place, right? They tried it on Snowflake, and they did a live connection, and the performance was where they wanted it to be, and so they could actually switch all of those extracted connections to live to the database. Now, when they run those queries, the other thing is that we just charge you for the time that the compute was running for. So if you ran a 2-node cluster for an hour, that would cost you 2 credits. But if you ran that same 2-node cluster for half an hour, it would cost you only 1. So it's actually per second billing that we provide, as opposed to just having to pay for the thing 24/7. So I guess bringing it back to those 5 key pain points and where Snowflake really sees value, sees customers gain value. First of all, the complexity involved in managing some of those other systems, we try to get rid of that. So our interface is really simple. We are SQL based, and so it's not a matter of having to find people with skills that might not be there yet. We're full service, right? So there's no tuning. Those micro partitions I talked about before, we also have tuning on top of that and optimizations for queries that's all built into the product. You don't even have to configure anything for that to happen. Scaling is easy because of the separation of compute and storage, right? So essentially, you're able to get that faster engine in a single click. Under the covers, we're managing a pool of servers for you, but essentially, you're not having to pre-provision or do that sort of work beforehand to plan. You can do it on the fly, you can do it on demand. As soon as you need that horsepower, it's there for you. Elasticity goes hand in hand with that scalability, right? It shouldn't take hours or minutes or anything. It should be seconds or less for you to get that extra horsepower when you need it. And then the costing. So again, the cost of S3 is the storage, which is usually not people's concern because it's cheap, but it's really pay for what you use. It's utility based. So again, if you run a cluster of machines for a small cluster for an hour or a large cluster for 15 minutes, the cost is actually the same. So you can think about a lot of the data science teams love that because they can say, run this model in a fraction of the time, not interfere with anyone else on the system, and it would cost you the same at the end of the day. And then finally, just the diversity of the data sources. So again, barring, not including the completely unstructured, but we're seeing semi-structured data, JSON data, especially coming from apps, clickstream data, IoT. We have a lot of IoT use cases. So again, being able to ingest that without having to predefine the structure means that you have full flexibility on the other end. And then you can combine it with your traditional data stores very easily in Snowflake. So I just want to end with a couple of things here. So we have a team in Singapore. We're actually going to be, at the moment, we're locally in the region only in Australia. But in 2 weeks or a few weeks' time, I think it's 2 or 3 weeks' time, we're actually launching our Singapore deployment officially. And so if you've been scanned at our booth, I'm sure you'll receive an invite for that launch. The second thing is we have a demo running at our booth. So 4 p.m. is the next one, so in about an hour. If you guys want to see the product in action, please come by. We're more than happy to share it with you. And then finally, we have a full trial available online. So if you go to our website and just search for Snowflake trial, we give you a month for free and $400 worth of credits to just play with. So try it out for yourself after you see a demo and hook your own data sources up to it. Hopefully it'll live up to what I've told you today. Thank you.